All right, so section 7.1 and 7.2 seems like an odd place to start, but it's because we're in the Algebra 1 textbook, but it actually won't be noticeable to you because it'll all populate in the same spot for you. So that's why it's a 7 instead of a 1. We're starting in the algebra textbook. We're going to go ahead and talk about adding and subtracting and multiplying polynomials. So adding and subtracting is actually in 7.1, and then 7.2 is multiplication of polynomials. So that's why we're just throwing it all together. It seems like something we can probably manage. Last class did, so that makes me think that we can also. All right, so first, some terms. You said you kind of knew what a monomial, binomial, trinomial was, so I'm not going to mess with that. If you need more help on that, I'll show you where you can get that in a minute. Let's do degree. Definition of a degree is the sum of the terms of a monomial, the sum of the exponents of the term of a monomial, which is really kind of wordy. What I want you to think about unofficially is the largest exponent. Unofficial, the largest exponent, if it's the degree of a polynomial. And actually the sum of stuff will come up in Algebra 2, but it doesn't come up on our assignment today. So I think I'm just going to let that lie. Just know that you've heard it. You are eventually going to have to, and I can show you one example, but if you want the degree of one term, you actually have to add the exponents of all the variables in that one term together. But the largest exponent's another way just to think about it. So let's do some examples. Let's see what this looks like. So here is a degree column. Here is the name column. And then let's do an example column. Okay, so degree, let's go 0. What was the degree of 0 on the video? Does anybody remember? What was an example that they used?
Just a number.
Good, just a number, like 6, I think it was. And I have those backwards, sorry about that. I'm so anxious about this camera working correctly that I'm not paying enough attention. This is called a constant. The constant is the name, and the example is 6. I had those backwards. So the constant is what you call that. 6, 10, 14. There's no variable, so there is no degree. A degree of 1. Anybody shout out an example they think they knew from the video? Do you remember?
5x.
5x, 2x, 10x. Perfect. Yep, degree 1. Obviously, there's not a 1 there, but that is where it would be. And this is called a linear. Let's go ahead and go take you to the way back files. But do you remember y equals mx plus b? Yeah, mx, that's your linear. I did a degree 1, so it's a linear. A degree 2, we could do 5x squared plus 1. It's not a monomial. It's actually a what? Binomial. Good, but that binomial has a degree of 2. Its degree is the largest exponent. So this degree of 2 is called a quadratic. A quadratic. And I don't know if you guys got into solving quadratics last year. I'd have to look again, remind myself exactly what it was. A quadratic. Okay, a degree 3, we'll go up to 5. 12a squared b. And I told you I'd show you an example. Here's your example. This is that sum of stuff that I said I don't necessarily know actually pops up on the textbook, but I still want you just to see it. It's an Algebra 2 kind of thing. The sum of, is this 12a squared b one term, a monomial, two terms, a binomial, or three terms, a trinomial?
Binomial.
Good guess, but no. This is a monomial. This would be a binomial. So here, this is one term together because it's all squished together. It's all multiplication. This separates your terms because it has an add or subtract there.
Okay.
So this one term, why does it have a degree 3?
Because A and B are part of the same thing.
Two exponents are added together.
Good. Yep, that doesn't happen very often, but it is good to know. It's largest degree. This is still the largest degree term, and it has a degree 3 because you have the sum of those exponents, and it is called a cubic. I won't make anything else that hard. Degree 4 could be 10y to the 4th plus 6xy to the 3rd. Oh, let's not make it that hard. Let's go y to the 2nd. Minus 2. Okay, so that is a degree 4. A degree 4 because it's the largest exponent. In terms of y, that's a degree 4. The largest exponent there. Is this a monomial, binomial, or trinomial? Trinomial. There you go. You got it. Good job. This is called a quartic. Okay, last one. You're almost there. Degree 5 is called a quintic. And it could be 7a to the 5th. Nice and easy. So degree 5 is a quintic. I don't think I need to highlight anything there because it's pretty obvious. So the degree of a term, a single term, this term by itself is degree 4. But then why is the degree of this whole polynomial 4 again? Good. So each term has its own degree, but then the whole polynomial has a degree too, based off of the largest term. Questions? What do you have? I'm making this harder than it needs to be. When you get to the homework, you'll see that it's a little bit easier than that. But okay, I want to show you. Yes, please.
So it's the largest exponent of a single term in the polynomial?
It's the largest exponent, good question, of the entire polynomial. So this is a whole polynomial built with the building blocks of two terms. So I have term 1 and term 2. So when I look at, in this question, this polynomial, because it's a binomial, what its degree would be, I would find the degree from the largest term. So you go, and this one's kind of, if I had to pick one to cross out, it would be that one. Let's focus on an easier one. This one has the largest exponent you can find. I have a 2, I have a 1, I have a 0, and I have a 4. Where's my largest exponent? And that's the degree of the whole polynomial. Okay, and again, if you're kind of confused, there will be something I'll put in place that will make it really clear.
Wouldn't 6xy have a degree of 3?
This would have a degree of 3. The whole term would have a degree of 3, but is that bigger than 4?
No.
Good. But that's exactly right. You're thinking about how we did this. Nice job. Perfect. Okay, so let's look at a subtraction problem quickly, and then I'm going to cut you loose. So the subtraction problem, can you see? People up here can see? Okay. People here can see. It's a juggling act up here, you guys. Here's what I want. I want 5 x squared minus 8x plus 8 minus 6x squared plus 5x minus 2. Okay, so adding and subtracting polynomials are very similar, so I'm just going to do subtraction with you because it's the harder of the two. Subtraction, the beast, because it's a leave, change kind of thing. But if we leave this, change this, how does that affect this, which is also needing to be changed?
You gotta change every sign.
Negative 6x squared, negative 5x, and positive 2. So it leaves this alone, changes subtraction to addition, and then everything behind it has to change to the opposite. If you don't do that, you'll end up with a small mistake, and you'll get right away cued into whether or not you're doing it right based on this new online textbook we're going to use. So then let's go ahead and combine our like terms. Which degree is the largest up here? Degree 2. Good. So let's start with that term. 5x squared and negative 6x squared will give me what?
Negative x squared.
Negative x squared. Good. Next, what's the degree of my next terms? 1. Good job. Negative 8x, negative 5x, negative 13x. Good. Oh, goodness, and I wrote a 12. Said 13. I wrote a 12. Negative 13x. And then the last two terms, my constant terms. What do I get when I combine those? Plus 10. All right. Now, I talked about them as individual terms, but the truth is this is one big polynomial answer. This is my answer. You don't have to put your answer in parentheses, but what I want you to think about it, you're thinking about this one thing, this one polynomial being created by a set of 3 terms. So terms are kind of individual, but they can be brought together in the umbrella of a polynomial. What type of polynomial is this when I put 3 terms together? A trinomial. What's the degree of the whole family, the polynomial? Degree 2. The whole polynomial, when it's put together, has a degree of 2. But each term has its own degree as well. This term has a degree of what? What does this term have a degree of? And this term has a degree of?
0.
But when they're all brought together, this largest degree wins. It becomes the degree of the whole polynomial. And the reason that is, the degree, the largest degree, tells you how many solutions this type of a problem has. This type of a whole trinomial has 2 solutions. So the largest degree tells you how many solutions you'll have. Which is why it's important to know. Okay, that's it. That's it for notes. Let's go ahead and get our textbooks out.